Welcome to Module 5, Lesson 5, Unit Circle Trigonometry. So in Level 1, we're going to look at converting between radians and degrees. The SAT often asks you to switch between degrees and radians when working with angles. So there are two conversion formulas that you should memorize. If you want to go from degrees to radians, it's radians equals degrees times pi over 180. If you want to go from radians to degrees, it's degrees equals radians times 180 over pi. So here I have a table with some common conversions for you to memorize, right? 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. These are the most common angles that you'll be working with, and it is worth it to just memorize what those conversions are into radian measure, right? Because they will come up very often. Please pause this video and work on the Lesson 5, Level 1 problems in the workbook. In Level 2, let's actually work on doing some converting, right? And we're going to look at some degree measures that aren't the common or typical ones like we looked at in the previous level. So let's convert 150 degrees to radians. So we're going to need our formula. Radians equals degrees times pi over 180. So we're just going to take 150 and substitute it in for the degree measure. 150 times pi over 180. That becomes 150 pi over 180, and we can reduce that to 5 pi over 6, right? If you can't reduce that on your own, you can literally just put 150 over 180 into the graphing calculator and have the calculator reduce it for you. Now let's convert 7 pi over 4 to degrees. So we're going to need our formula. Degrees equals radians times 180 over pi. So we'll substitute 7 pi over 4 for our radians. And we get 7 pi over 4 times 180 over pi. That becomes 1,260 pi over 4 pi. And we can simplify that to be 315 degrees, right? The pi's divide out. 1,260 divided by 4 is 315. Please pause this video and work on the Lesson 5, Level 2 problems in the workbook. In Level 3, we'll look at the sine, cosine, and tangent of common radian measures, right? So these are the common angle measures that you'll look at. And it is worth it to memorize or just become familiar with the sine, cosine, and tangent of these angles because they come up very commonly. We can use radian measures to calculate arc lengths and sector areas just like we can with degree measures. So the formulas are similar. The central angle over 2 pi equals the arc length over circumference, which is equal to the sector area over the circle area. So the central angle over 2 pi, right? So 2 pi is the radian measure of 360 degrees, right? 360 degrees is 2 pi. And 180 degrees is pi. So even just knowing that pi is equal to 180 degrees and 2 pi is equal to 360 degrees, that is a really good thing to know because it will help you figure things out when you can't remember the other radian measures. So let's take a look at an example. A circle has a radius of 6 centimeters. What is the area of a sector with a central angle of pi over 3 radians? right? So we just did problems similar to this. Now the central angle is in radians. So we're going to need the central angle over 2 pi equals the sector area over the circle area. So let's substitute into the formula. We'll get pi over 3 over 2 pi equals x over pi 6 squared, right? Just substituting 6 for our radius. We can simplify and we get pi over 3 over 2 pi equals x over 36 pi. Now we can cross multiply. We get 2 pi x equals 12 pi squared. So we'll divide both sides by 2 pi, and we get x equals 6 pi. So the area of the shaded sector is 6 pi. Please pause this video and work on the Lesson 5, Level 3 questions in the workbook. Once you're finished with the problems in the workbook, please move on to the next video for Lesson 6.